Alright, let's just double check that the stream is actually alive. Alright, I see. Looks like we're all good. Okay, so let me just shove restream all the way here so I can forget about that. Um, alright, so it's like 3:23 a.m. in the morning. Wow, that was extremely redundant, but basically what we are going to be doing today is I'm just gonna try my best to keep my sanity while actually, getting some schoolwork done, which is for my advanced databases subject or class rather. So let's actually see what we can do. So our project, just for a little bit of context, is actually geared a lot on. Yeah, here it is. Okay. Our project is actually geared quite a bit on data insights. So let's actually get the SQL file that we're going to be loading into our local server so we can actually start with the what we actually need to do. Okay, looks like our data warehouse is going fine. So just a little bit of context. Basically, we are working on the IMDb dataset, IJS dataset that we could get from the MySQL repositories of public databases or public datasets. And basically, we ran that through an ETL script via Apache NiFi and essentially placed that on how do you call this? Essentially placed that on our local MySQL instances. So, and I'm running an M1 MacBook. That's why I have quite the problem of actually trying to get the ETL script to run, because Apache NiFi itself doesn't even want to start. So I have to get the SQL file from someone else, from one of my group mates in class, and actually be the one to manually place that into the server. All right. So what I will be doing first is in the local database server that I have here, I want to actually first rename the database. The old database, just so that I keep it here. So MCO1 warehouse old, I guess. So let's actually search up MySQL documentation on how to actually rename. MySQL how to rename database. Alright, let's see what we can get here. Change schema name. So I think this is alter schema. Never mind. It's rename table. So that's a lot easier than I thought. Wait, no, that's a table. Okay. So basically, we're like creating a. Okay, fine. You know what? I don't think it matters that much. You can just retain the old name. So let's go ahead and import the data through an SQL file, which I have in my downloads folder here. So let's go get that real quick. MCO1 final warehouse. All right, let's get that there, and let's actually create a new schema. Otherwise it is okay. Yeah, MCO1 warehouse final. So we're gonna dump both the structure and the data. So let's import that into our database, and let's actually start working on it. So the OLAP application that I'll be using for this homework, for this major course output, is Tableau. So we were able to get a copy of Tableau Student because we do have our university email addresses that we could use for it. So while that imports, let's actually set up our Tableau here. This is the old one that I've been working on. The problem with this now is because we do have an outdated schema. So as much as I hate to do it, I have to like completely abandon this and like get a brand new data source from our warehouse here. Since we're changing databases, there we go. So the import has finished. So let's go ahead and check our updated database. So show databases. We have MCO1 warehouse final. Perfect. Exactly how we want it to be. Now, before actually touching this, is there a way I can refresh this? Refresh. Before actually touching Tableau, we need to fix these because I've designed these queries to work with the old version of the schema that we had. The problem is we did change the schema, so we're gonna have to reverse engineer it so we are able to actually work with the new schema. I mean, the data is the same, it's just that it's represented in a different way. So we have to review the new schema, which is not here for some odd reason. Where is it? It is not here. Let's try import doing that again. Database reverse engineer, local database server, continue, and we're gonna use MCO1 warehouse final. Finished. Okay. Place. There's nothing here. There's nothing here. It's an empty schema. Did I not import the... Okay. Let's see what we have. Use MCO1 warehouse final. Okay, and show tables. We have nothing here. Alright, we have nothing here. Drop database MCO1 warehouse final. Let's kill off that database and flush privileges. And let's do that again. So server data import. And let's go ahead and re-import that again. Over in my downloads folder. Alright. And new schema, which is MCO1 warehouse final. The problem is I think this has a create schema, which means I am definitely gonna need to rename my database. Otherwise it's gonna conflict. So let's see. If we leave that blank, this is supposed to cause a conflict issue because there's already a database with that existing name, so that can't happen. Let's see. All right. Import did complete. Let's see what changed. Show databases. I know I left the blank. Okay. So we have the same one. And let's actually show the tables. Yeah. I don't think this is the updated one. I do have a copy of the SQL, so I guess I'm just gonna yeet this old schema away and let's just completely use the new schema out of the bat. So let's do that. Drop database MCO1 warehouse. And we'll just flush privileges. I spelled flush incorrectly. Flush privileges. Okay, and we'll do that same import again. While that's running, I'm gonna go get some coffee. Give me a sec. Alright guys, I'm back. Looks like the import completed without any hiccups. That's good to hear. Let's inspect. I am guessing the MCO1 is here. That is perfect. Use MCO1 warehouse. Perfect. Show tables. Perfect. Okay, so let's go ahead and do the reverse engineer and actually see what our schema is made of now. MCO1 warehouse. Alright, now let's see how it looks like. Where are the relationships? The relationships are gone. Okay. Genre ID, we have the ranks. Looks like the ranks is the fact table here. So this is what actually has all the relationships. So let's actually edit the relationships in. So this one, oh my gosh, I think I probably might have forgotten how to use this. It's been so long since I had this class. How do we set a foreign key? Here. And click to edit. So reference table would be actors. Yeah? How do I set that? There, okay. First is our actor ID or movie ID, which does reference to movie ID. The software is lagging as usual. Let's see how we're doing on YouTube. Where'd YouTube go? Alright, anyway. Let me just close that out. Okay. Or could probably keep that open. It's just that I'm gonna mute the tab. Yeah. Okay. Let's mute that tab. Alright. Let's see where we are going wrong here. Software is not responding. Yes, it is responding. Okay. So movie ID, we want to reference movies. So precisely like that. So a movie, or so let's see if the relationship is correct. So for one movie, there can be multiple rankings. Rank is a year and a float. Okay, that's not right. One is too many. One movie can be multiple ranks. That's not right. Okay, let's see if I can remember how to use this software. I don't know. We'll see. All right, let's have the next one. We have actor ID. Actor ID actually references the actors table. So MCO1 actors. So is the relationship correct? One actor can have many movies. That's correct. Okay. Next is let's have the genres now. Genre ID. I know that's a thing. Alright, and the last one should be directors. So director ID. And let's head on over to the directors. Now the relationships really don't sit well. They're not correct. So let's see what we can do. For the foreign keys, I don't see anywhere where I'm able to change it. Do I just select this and change? What happens if I click this? I'm supposed to drag. Okay. Let's see. Okay. I know that this is 1-to-1. Oh, no. No. No, 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 no. No, 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 no. Delete. Okay. For this specific relationship, is there any way you could change the relationship? Foreign key. Here it is. This is 1-to-1 for movies and ranks. For genres, they can actually have multiple genres for a single movie. So, it's the reverse. How do we put that in reverse? It may be the case. Yeah, that's in reverse. You know what? Okay, fine. I'll stop caring about the relationship for now because I need to finish this. Okay, now let's actually try to convert the queries that I've written here. This one, I'm not sure if I want to keep this. I don't know. I'll just keep it there, but this is what we're trying to focus on. So how many actors tagged to each genre? So if you look at the new EER diagram, we've actually changed quite a bit from the last one. So let me just hide this down. How do I do that? No, not like that apparently. Alright. So it did change quite a bit. So for the genre table here, we have actors A. I know actors remained. And it has its actor ID. It doesn't have its movie ID anymore though, since we're referencing everything from the ranks table. So everything has to go from the ranks tables. How many actors tagged to each genre? So let's run this query and let's try to get... Oh yeah, okay, I forgot that this no longer runs. Okay, let's create a new version of that here at the bottom. And then we'll just overwrite that once we're done. How many actors are tagged to each genre? So select count a.actor ID, because that's the identifier for that. So actor count, we're gonna retain that, and we're also gonna get g.genre. So let's actually see the genres table. So that's g.genre indeed. All right, from they're different now as its ranks are instead of actors A, and we want to do an inner join towards actor and genre because they're the two tables that we actually need to connect to. So let's have actor A on i.actor ID. Okay, now that I think we do have a problem. Actor ID. It's just that for a single movie, you can actually have tons and tons of actors. Now this is a problem. This table, the ranks table, is going to be tremendously... okay. I understand. Alright. How many actors tagged to each genre? We're actually gonna have to start from the actors table. Select count a.actor ID as the actor count, and let's grab the genre from actors A, and we're gonna have to join the ranks table. Ranks R on r.actor ID is equal to a.actor ID. At the same time, we have to join the ranks to the genres, so which is right here, which we can get from our genre ID. So that's going to be genres G on r.genre ID is equal to g.genre ID. So we have those set. How many actors tagged to each genre? So let's group by the genre, no? So group by the genre, and we're probably all set. So let us see if it does. Oh, I forgot to create indices for the new tables. Drama actually has more now compared to my tests earlier. So let's have, we're gonna have to decide on that or see. So let's do the optimization first. What can we optimize in this? These are all primary keys. Movie ID, actor ID, director ID, genre ID are all primary keys. So show, how do we show all indices? Show all indices in MySQL. Show index from table. Okay, let's try that. Show index from, I'm inclined to say all. I don't think that's gonna work. It's not gonna work. From ranks. So we have all the primary keys and they're all set up. Binary tree. So we have no issue there. Next is, we might have to index the year and the rank itself. Okay, they're not string, so that might be kind of an issue. Let's try. Create index IDX year. And how did this work again? I know I had an index code here in a bit. On. We have to use the keyword on. Alright, so on ranks and then year. Let's make that index. It's indexing right now. It's 1 million data points. Alright, cool. So that's the year. Next, we would need to do, these are all the primary keys. Genre could be indexed. Create index IDX genre name. On genres genre. I believe that can be indexed. Next is director, I'm not sure. Actors, I'm not sure either. Movies tend to have a unique name. So the movie name, we can actually index that. But the problem is, when do we actually need to index a movie name? Usually when you index stuff, it's usually because it's gonna be like really used for the order by operation or the where clause. But I don't see the name being used there anytime soon, so I probably don't need to index that. All right, let's head on down. And actually do try to convert our queries here. So this is an issue. And the reason why this is an issue is because it does not return what I've expected it to return. Drama, I know, is like 100,000+, as you could probably see by our tableau. Okay, yeah, alright, let's actually fix this one too. Refresh, I can't refresh again. So let's go ahead and remove all of our data sources. MCO1 warehouse, refresh. Hmm. That was relatively quick and refreshing, huh? Okay. Yeah. That's an issue. So, movies directors, we don't have these tables anymore. And so let's remove all of them. Not rename. And removed. We know that our center is ranks first. And after ranks, we do have the movies table. Then we have the actors table. And then we do have the genres table. And then the directors table. So that's 5 tables in total. Alright. So now if we try to get back here, which we're going to remove here, I want to know the distribution of actors across all sorts of genres. How many actors are there in each genre, and maybe how many actors are exclusive to a specific genre? I think those are semi-interesting questions to ask, I guess. So what we're trying to do here is exploratory data analysis, and we're trying to find any trends in the data that we actually work with. Let's check it out. So our column is, we want to think about the genre. So let's actually get our genre here from our columns. And that's gonna have to be the genre name, which is a column right there. So we do have action, adult, etc., etc. And after that, we're gonna need our data that we need to pull in. So now with this brand new, what do you call this? With this brand new schema, what new data do we have to pull in? So for rows, this is an aggregate, but we're not looking for directors. We're looking for the actors. The problem is actors doesn't really have a direct connection to genres, so we have to pass by the ranks to try and get that connection. So let's go to actors and the count. Let's get that here. Let's see what happens here. Alright, this actually does make sense. Drama has 382,233 entries. Let's actually arrange that. Let's see if this actually does align with our SQL. It does not align. It does not align one bit. Okay. Counting the actor ID as actor count, when that is grouped by the genre, starting from the actors table. And these are inner joins, so we're only taking the center of the Venn diagram. So technically this really should make sense, but right now it's not making any sense as to why the data is like this. See why I'm having a hard time? I don't believe it to be like this at all. Count of actors 1. What is actors 1? So we do have the actor ID and the gender. Okay. So the genres are connected to the ranks table via the genre ID. And we have to start thinking about what kind of relationships actor has with ranks and what kind of relationship rank has with genres. So let's go back to the EER diagram again. Don't mind the misleading arrows there, because well, it really isn't like that. Let's try to solve that on our own if my internet doesn't cut me off at any moment in time.